Hi, Algebra 2. Welcome to section 4.8. This is going to be the last section we do in chapter 4. And for some of you, you are very excited to hear that because I know quadratics have been a little bit challenging for us, which is okay. Quadratics are usually there's a lot we talk about with quadratics, so we got to go into detail with it, and some of the details are a little there's a lot to deal with, right? So we'll be going ahead and moving on to some new and hopefully greener grass in chapter 5, okay? But for now, let's just kind of finish off on a lighter note with the quadratic formula and a little bit about the discriminant, okay? I think by this point you guys know quadratic formula, but let's go ahead and, okay, I didn't know what that red circle was. Hopefully it's nothing terrible in the top left. Let's go ahead and finish up with quadratic formula. So kind of what I want you to take out of this is I want you to be able to use the quadratic formula to solve quadratic equations, the basics, right? And then I want you to be able to use the discriminant, and maybe you're familiar with this term, maybe not. We'll see what that is in a few minutes. I want you to use it to identify the number and type of solutions of a quadratic equation, because sometimes that's really all we care about. Sometimes we care about, oh, what kind of solutions this is going to have, because remember when we solve a quadratic equation, sometimes that models like the x-intercepts or some other pretty important points on the parabola of the quadratic. So sometimes we just care about, does this have x-intercepts? And usually the discriminant can tell us immediately if we aren't able to graph it right off the bat. And then lastly, we want to use the quadratic formula to find x-intercepts, which we have been already, right? And then some other x values of a quadratic function given different y values. Sometimes we're not just concerned with x-intercepts, okay? And that'll be kind of where we end towards the end of this video. So let's start with the quadratic formula. The whole point of it is to give you one last tool in your quadratic equation solving toolbox, okay? Because now you have a lot of tools. You have factoring, you have using square roots, you have completing the square, and then now you have the quadratic formula, okay? So kind of an important note to make. The times that we can use our quadratic formula is when our quadratic equation looks like this. Standard form for a quadratic equal to 0, right? We're used to this by now. We're used to this whole idea of we need to make sure that this is set equal to 0 before we can do anything with it, especially when we factor, right? When we factor to solve. So the quadratic formula says that the solutions of the quadratic equation, boom, are, so we usually take this part for granted when we do our quadratic formula, but you're solving for x at the end of the day. So you need an x equals, even when you're doing quadratic formula, right? Equals negative b plus or minus the square root of b squared minus 4ac divided by 2a, right? Maybe you remember the song. It goes to the tune of, I think, Pop Goes the Weasel. Hopefully that helps you to remember it. You don't have to memorize it in this class, but I really kind of do encourage you to do so because you're gonna, it helps, right? It helps to kind of not have to flip back to a page in your notes that you might not remember where it is just to find the quadratic formula, right? So, let's go ahead and just use it. Let's look at our first example. Solve the following quadratic equations using the quadratic formula. So the very first thing we usually want to do is, well, it needs to be in that form, standard form equals 0. So here we don't have an equals 0 quite yet. We need to get rid of this 2, move it to the other side. So minus 2, minus 2. X squared plus 3x minus 2 is equal to 0. All right, so normally we'd ask ourselves, because sometimes factoring is a little bit easier, especially if we're good at factoring. Can we factor this? No, there aren't any factors of -2 that would add up to give us +3. So that's kind of where our predicament starts, right? That's where factoring doesn't work. Completing the square is kind of tedious. We can't use the square root here, so we go ahead and we rely on our quadratic formula. Let's first identify all the coefficients. We see that our a is 1, because that's the coefficient on our x squared. The coefficient on x is 3, so b is 3. Coefficient on our constant term, actually, is -2, so that's our c. Okay, so now let's just jam it all into the quadratic formula. X equals, always remember that, negative b, so negative 3, plus or minus square root b squared, so 3 squared, minus 4 times a, which is 1, times c, which is negative 2, divided by 2 times a, and a is just 1. Awesome, we plug stuff in. Let's go ahead and clean this up a little bit. Negative 3 plus or minus square root of 3 squared is 9, minus, so we have negative 4 times 1, which is negative 4, times negative 2. Since it's a negative 4 times a negative 2, that becomes plus 8, right? You want to always be careful with your signs when you're doing the 4ac part, right? Careful with your signs. Divided by 2. Okay, so let's go ahead and one more cleanup. We got x is equal to negative 3 plus or minus 9 plus 8. That's rad 17 over 2. Okay, now to be a little bit stingy, we can take this one more step. This is technically negative 3 halves plus or minus rad 17 over 2. This is totally appropriate, this first thing that we found. But a lot of the times you're going to see the answer also expressed this way. So I'm giving you both, or I'm showing you both. That way, if you ever see it written one way or the other, you're like, oh, those are both the same, right? Boom, we found our solutions. Okay, not too bad at all. And you're probably sitting here thinking, wow, that is so much easier than when I had to factor and when I had to complete the square and when I had to use square roots. And you're right, it usually is a lot easier. Just keep in mind that sometimes we will be, it's a lot easier to factor, sometimes it's a lot easier to use completing the square. And the reason why is because those things tell us information that the quadratic formula doesn't, right? When we factor, we immediately get those x-intercepts. When we go to vertex form, when we complete the square to get vertex form, we get the vertex, and the quadratic formula doesn't necessarily give us the vertex, right? So just kind of some things to be aware about. Next example, let's do the same thing. First thing we got to do is we got to make sure this left-hand side is a beautiful 0. Subtract 5 over, we get negative x squared plus 4x minus 5 is equal to 0. So now what's our ABC? A is negative 1, B is 4, C is negative 5. Awesome. Let's go ahead and quadratic formula it up. It's going to be negative b, so negative 4 plus or minus the square root of b squared. I'm going to skip a step and just say, well, that's 16 minus 4 times negative 1 times negative 5 divided by negative 2, right? Because 2 times negative 1 is negative 2. Let's keep going. Negative 4 plus or minus the square root of 16. Negative 4 times negative 1, that's positive 4, times negative 5 is minus 20. Uh-oh, I foresee some scary territory. Let's keep going. Equals negative 4 plus or minus 16 minus 20, that's negative 4. Negative under the radical, that's okay though. We know how to deal with that. Negative rad negative 4. Well, we know we can factor out an I because that negative I can factor out as a good old I, but then the square root of 4 is 2. So let me do it on the side. That way we see the full process. Square root of negative 4 is equal to I rad 4, but then rad 4 is just 2, so 2I. So we get negative 4 plus or minus 2. I don't know what that was doing. 2I over negative 2. And now the last thing we got to do is divide that negative 2 through. In this case, we can. And when we can, and when we do divide it through, we got to divide it through to both terms. Okay? So negative 4 divided by negative 2, that's positive 2. Plus minus 2I divided by negative 2. Well, the plus minus doesn't really get afflicted because the positive turns negative, the negative turns positive. you still got plus minus, so there's no change there. Plus minus I. Awesome, right? So there is our solution. X is equal to 2 plus minus I. And remember, this plus minus is shorthand for writing 2 plus I, 2 minus I, because if there's anything that a mathematician is, it is lazy, right? Okay, there's our answers. All right, one more example to kind of make sure we are good to go. Let's do some bigger numbers, y'all. Okay, first things first, make sure there's a 0 on the right, subtract 12x, and we can be big kids. Let's go ahead and subtract 12x and add the 9. We're gonna do 2 steps in one. You don't have to if you don't want to. You can do it 1 step at a time. But just kind of for time's sake, I want to make sure I'm respectful of you guys' time. I'm just kind of doing 2 steps at once, okay? 25x squared, negative 18x minus 12x, that's going to be negative 30x. There is no constant term here, so it's just plus 9 equals 0. Awesome. A is 25, B is negative 30, C is 9. Quadratic formula time. X is equal to negative B, so negative 30, that's positive 30, plus or minus. Square root of 30 squared, that's going to be 900. Minus 4 times 25 times 9. Divided by 2 times 25. Awesome. Keep going. 30 plus or minus 900. What's this right here when we calculate it? You're going to find that it's also 900. Uh-oh. Times 2, or divided by 2 times 25. 900 minus 900, that's our favorite number ever in the world, 0. So plus or minus 0, we don't care about that because plus or minus 0 is still nothing. Divided by 50. 2 times 25 is 50. 30 divided by 50, that simplifies to 3/5. Cool. This time we actually only got 1 answer. We're used to seeing 2 from that plus minus, but here we only got 1. Cool. All right, so kind of review a little bit what we just did. We used quadratic formula, and if you notice, we got 3 different types of answers. In this first one, we got 2 real numbers, right? There's no i's here. In this second one, we got 2 complex numbers. And in this third one, we only got 1 real number, okay? So meet me in the next video and we'll kind of talk about why that is. All right, see you there.